Stan Gibilisco here to discuss a very basic concept in electricity, the three ways that a wave phenomenon can vary. We can vary the amplitude or signal strength of the wave. We can vary the frequency or the number of cycles per second in the wave. We can vary the phase or the positions in time that the wave crosses the time axis. That's a little bit more sophisticated concept to describe in words, but I'm actually going to show you with pictures what it looks like. Here we have on the horizontal axis of a graph time, going from the past on the left to the present. That wave doesn't want to stay still. To the present, to the future on the right. The instantaneous or moment-to-moment positive or negative voltage is indicated on a vertical axis, and here we have a very simple waveform known as a sine wave, recurring at specific intervals like this on the time axis. If we vary the amplitude of this wave, what does that actually look like? Let's just say that we increase the amplitude to 150% of what it was. That is, we make it half again as strong. That's what happens. If we don't change the frequency or the phase, that's what it looks like. If we make the amplitude only half as great, it's going to look like this. Same frequency, same phase, half the amplitude. Now let's see what happens when we change the frequency. What does that look like? Well, let's suppose that we double. Well, no, let's not double it. Let's increase it by a factor of 10% so that the frequency becomes 10% greater than it was. What does that look like when we do that to a wave? Well, I can manipulate this little graph and show you that. The wave crosses the time axis more often, 10% more often to be exact. What happens if we, say, cut the frequency in half? Well, if we cut the frequency in half, the wave is going to cross the time axis only half as often, or the interval between positive going transitions here and here and here, each cycle will take twice as long. Frequency and period are related inversely with respect to each other, and that's another concept that perhaps we should think about, even though it's related to frequency. The period of a wave is the length of time it takes for one cycle. The frequency is the number of cycles per unit time. So we might talk about cycles per second for frequency and seconds for period, or cycles per microsecond for frequency and the period in microseconds, things like that. So that's what we have in this case. Now let's restore the wave to its original stature and think about what happens when we vary the phase of a wave. Well, in that case, the frequency and the amplitude stay the same, or let's just assume that they do. What happens to the wave? It moves either to the right or to the left along the time axis, like that. So those are three different characteristics that we can vary in a wave phenomenon. We can vary the amplitude or signal strength. We can vary the frequency, which also varies the period. Or we can vary the phase, which varies the horizontal position of the wave on the graph as we see it here. Stan Gibilisco signing off. Hope that clarifies that concept for you. It's very basic, but can be rather confusing at first. So long.